These are the practice problems for Unit 3, Linear Relationships, Lesson 3, representing proportional relationships. And this is practice problem number 1. And in this problem, what you are supposed to do is use this graph. They give you this graph. You're supposed to write the equation for this graph and use that equation to calculate some values in the table that's provided for you. So in writing the equation, look at the line. So this is the line for that equation, and find places where that line intersects with where the grid lines intersect. So this is the vertical direction, this is the horizontal direction, where those two lines intersect with the line of for the equation or the graph. That gives you a point that you can use to write the equation. And so if you continue up this line, this graph, the next time that happens, it's not a surprise, it's 2 times 100, so at 200. So you could use these two values. This is 200 and this is 300. You could continue up. The next time it crosses, it intersects with the grid lines, is 3 times 100. So you could use these two values, 300 and this is 450. So that provides you with easy numbers to use to write the equation. So in this case, because this is a proportional relationship and because this slope triangle goes right up against the origin, you don't have to subtract or add anything to the x and y values to write the equation. So that means that this vertical direction, the number of units in the vertical direction, is the y coordinate. So it is this y coordinate, which is 150. The number of units in the horizontal direction is the x-coordinate. This is this x-coordinate right here, which is 100. And is that ratio, the ratio of the number of units in the vertical direction to the number of units in the horizontal direction, that gives you the constant of proportionality, which actually is also the slope. So it's the value, it's the number of units in the vertical direction on the y-axis over the ratio to the number of units in the horizontal direction. So again, it's easier to write. It's just using y and x because this slope triangle is right up against the origin. And so you can go through the exercise of subtracting the origin. It's just y minus 0 equals y, and x minus this 0 right here equals x. It's going to give you the same amount, the same number, 150 over 100. That simplifies to 1 5/10 or 1 1/2. So y is 1 1/2 times, or 1 5/10 times, more than x. So whatever the x value is, and in this case it's 100, y is going to be 1 1/2 times that value, and in this case it's going to take you up to 150. So this tells you what the equation is. So y is 1 1/2 times greater than x. So then you can just write that. Y is equal to 1 1/2 times x. This is the equation. You're going to use this equation to fill in this table. So y equals 1 1/2 times x. So remember that y over x is the constant of proportionality. So 1,000 times 1 1/2 is going to give you, so what's 1 1/2 times 1,000? Well, it's 1,500. So if you have 1,000 grams of fish, how many calories do I need to add to the fish tank to feed those fish? I need to add 1,500 calories, 1 1/2 times as many grams as I'm given. Now the next problem, we're going to come back to this, I believe. Yeah, we're going to come back to this in a moment because now we're going in the opposite direction. You're given the number of calories. So if you know this constant of proportionality, how do you use that to calculate the grams of fish? A little bit more required to think about that. It's not quite as obvious in this case. But the last one, 1 times 1 1/2. So it's 1 1/2 times 1. So you have 1 gram of fish. How many calories do you have to add? 1 1/2 calories. 1 1/2 times 1 is 1 1/2. All right, so going the other way. If you are multiplying by the constant of proportionality to get the y value, then to go the other way, you're going to divide by the constant of proportionality, which is the same thing. This gets hard to think about, and I actually added extra video to go into this in a little bit more detail. I'll show you that in a moment. But 2,100 calories, you divide that number by 1.5. That's the same as multiplying by the reciprocal of the constant of proportionality. So the reciprocal of 1 5/10 is 1 over 1 5/10. If you look at it closely enough, you can see that that's the same as dividing 2001 by this 1 5/10. 2001 divided by 1 5/10. So you divide by the constant of proportionality to go in the opposite direction. So 2001 divided by 1 5/10 is going to equal what x is, and that equals 1,334 grams of fish. So if you have this many calories, you can feed 1,334 grams of fish. So remember that the reciprocal of the constant of proportionality is 1 over the constant of proportionality. So to go the opposite direction, you multiply by that reciprocal. That's hard to understand. You have to work through a number of examples to really start to just understand it and be able to easily use that idea. So here's a link to a video that I put together on multiplying by the reciprocal. And here's a QR code that you can use your iPad or phone to just scan this in and take you right to the video. I will put this link in the discussion of this video down below this video in YouTube. This is problem number 2. And in this problem, you're given the information that you're selling raffle tickets. And in this case, you sell 10 raffle tickets and you make $24. So based on that information, you're supposed to construct a graph. You're supposed to label the x-axis the number of raffle tickets, and that makes sense. If I sell 10 raffle tickets, how much money do I make? That's the x value. And so how much money do I make based on selling 10 raffle tickets? That's going to be the y value along the y-axis. And that's going to be the amount of money. And in this case, the amount of money per ticket for one ticket is $2.40. So that's going to be the constant of proportionality. For every ticket, you make $2.40. And that's also going to be the slope of the line. And it goes through, it's a proportional relationship. It goes through 0, 0. So the equation is pretty easy to write. So y over x is going to be that ratio of $24 for every 10 tickets. So the constant of proportionality is going to be k, y equals kx. That's both the slope and the constant of proportionality. And so first of all, as we draw the graph, you have to go out, they want you to go out to 1,000 tickets. So you have to get 1,000 tickets on the x-axis. And it looks like if you just try a few different numbers, if you count by 100, that's going to get you out to here as 1,000. That looks like it's about the best that you can do. And so the amount of money that you make for selling 1,000 tickets is actually $2,400. And so this axis has to go up to $2,400. And it looks like you're going to have to count by 200s to get there. So if you count by 200s, this is $2,400 up here, and this is $1,000. So where those lines intersect, drawn from, actually you can call it a ray, arrow, where those rays intersect from 1,000 going up the y, along the y-axis, and 2,400 going along the x-axis, where they intersect, that's a point on the line. That's the relationship between the number of tickets sold and the amount of money that you make. It also goes through 0, 0, so you can draw that line. So draw that line, then you can test it. So if you sell 500 tickets, how much money do you make? Well, it's $2.40 for every ticket. So 500 times $2.40. So here's the equation right here. The amount of money is equal to $2.40, or 2 4/10 times the number of tickets. So M equals 2 4/10 times R. And what that's telling you is that in the vertical direction, that's always going to be 2 4/10 times farther times the measurement, the number of units in the horizontal direction. So you know the measurement in the horizontal direction, the measurement in the vertical direction, which is the amount of money, is going to be 2 4 times that. So 2 4 times 500 is 1,200. It's half of 2,400. So you go out along the x-axis to 500, and then you go 2 4 times that along the y-axis. That gets you out to 1,200, and that is right on the line. So it makes sense. So this checks that this is the proper graph. A couple of points check and fall right on that line. And if you look at a slope triangle, the distance along in the vertical direction, or the number of units in the vertical direction, is going to be 2.5 times the number of units in the horizontal direction. So if the number of units in the horizontal direction is 200 in this case, well, what's 2 4 times 200? It is $480 that you're going to make off of selling 200 tickets. So you go up here, 480 is about 500, so it's about halfway in between 400, 600. So that looks like it's about correct. Looks like it's in the right spot. 24 tenths, if you just say this, 24 tenths, and then write it, that is 24 tenths. We usually don't say that. We say 2 4 tenths, but actually 2 whole dollars is equal to 20 dimes. So it's the same as 20 tenths. Plus 4 more dimes would be 24 tenths. So that's it. So here's the equation. The amount of money equals 2 4 tenths times the number of raffle tickets. And because it's a proportional relationship, it goes to the origin. You just use y and x to write the equation. You don't have to subtract anything from y or add anything. You don't have to subtract anything or add anything to x. It's just y over x is equal to the constant of proportionality, and so y is equal to that constant of proportionality times x. Problem number 2. This is problem number 3. In this problem, you're supposed to show how you know when the slope is equal to 1, when the slope is greater than 1, and when the slope is less than 1. Well, in this example, if you draw a graph with the scales that are the same, so the size of the units on each axis are the same. So this is 1 unit, 2 units, 3 units in the horizontal direction, along the x-axis, and along the y-axis it's about the same, or it's trying to make it the same, 1 unit, 2 units, 3 units along the y-axis. Well, then if you look at the number of units in the vertical direction compared to the number of units in the horizontal direction, if they are the same, 2 units in the horizontal direction to 2 units in the vertical direction, then that has a slope of 1. So it's going in the vertical direction 1 times as much as it is in the horizontal direction. But if you keep the scales once again the same, 1, 2, 3, and 1, 2, 3, but if the number of units in the vertical direction is a fraction, small, compared to the number of units in the horizontal direction, then this is a slope of less than 1. Actually, this is much less than 1. This has a slope of 1/10. So in the vertical direction, it's 2 tenths. In the horizontal direction, it's 2 tenths. The ratio of 2 tenths to 2 is actually 1/10. So it's 1/10 as the number of units in the vertical direction as compared to the number of units in the horizontal direction. So this is a slope that's a small slope, much less than 1 of 1/10. And again, if you keep the units on the axis the same, so 1, 2, 3 along the x-axis, 1, 2, 3 along the y-axis, if the number of units in the vertical direction is more than the number of units in the horizontal direction, so this is 2 times as much, so this has a slope of 2. So in the vertical direction, it has 3 units compared to the horizontal direction, which is 1.5 units. that works out to a slope of 2. So in the vertical direction, it's 2 times the length that the slope triangle is in the horizontal direction. So this is, all three of these are with the scales being the same size. But if you, all right, so vertical direction equals the horizontal direction, it's a slope of 1. Vertical direction is less than the horizontal direction, it's a slope less than 1. And vertical direction greater than the length or the number of units in the horizontal direction, that's a slope greater than 1. But look carefully at the scales in this case. This is 1/10, 2/10, 3/10 along the y-axis, but units 1, 2, and 3 along the x-axis. Well, you just look at this and you might think, oh, that has a slope of 1. It looks like it's going up in the vertical direction as much as it's going out in the horizontal direction. But you have to look at the scales. In this case, the vertical direction is 1/10 the number of units in the horizontal direction. So this is this example is 2/10 in the vertical direction and 2 whole units in the horizontal direction. That is a slope of 1/10. So in the vertical direction, it's much less than the number of units in the horizontal direction. So this has a slope much less than 1. So you have to take care and be careful to look at the size of the units on the scales, because one could fool you if they're trying to make a point, could fool you if they change the numbers on the scales, or you could be fooled. Let's say that they're not trying to fool you, but you could look at the data incorrectly if you're not paying attention to the size of the units on the scales. So look at the scales. The y-axis is in tenths units. So in this case, the slope is much less than 1, even though this graph looks very much like this graph up here where the slope is 1. So the point of this activity is to pay attention to the size of the units on the scales, and also to understand when the slope is equal to, less than, or greater than 1. This is problem number 4. And what they do in this case is they give you this equation, y over x minus 2 equals 3/11. And they ask you to identify some coordinates, label some points that are on that line. So first of all, find some points on the line, draw the line. So draw the graph and label some of the points. So this is the end of problem 4. So I'm showing you everything at once so that you have an idea of the direction that we're going to go. So notice that we're going to use this slope triangle right here to write this equation. Now, it doesn't ask you to do that, but I'm going to go through how they get this equation. How do you come up with this equation? You use the slope triangle. You notice that this slope triangle actually has moved over a couple of units, 2 units along the x-axis from 0, 0. So this tells you that this is not a proportional relationship. It does not go through 0, 0. So if you increase the value of the y coordinate or the x coordinate, you're not going to increase the y coordinate in the same way. You're not going to, if you double the x coordinate, the y coordinate is not doubled. It's something other than being doubled. So this is not a proportional relationship. So how do you find the coordinates? The equation they give you, and also we're going to build some values in the table. So this is the table down here. So these are the x values. So 13, 24, 2, 7.5. And these are the y values that you get from these x values. So 3, 6, 0, and 3/2. So notice that if you use 3 as the starting point, 2 times 3 is 6, so this y coordinate is 6, but 2 times 13 is not 24. So again, this is not a proportional relationship. And half of 3 is 3/2. Well, half of 13 is not 7.5. Half of 13 actually is 6.5, not 7.5. All right. So how do you come up with that equation? So this is the slope triangle, and that equation tells you that the number of units in the vertical direction is 3 units compared to 11 units in the horizontal direction. So they're telling you that the number of units along the y-axis is 3/11ths of the number of units along the x-axis. And notice 3 is a little bit more than 1/4 of 11. So 1/4 of 12 is 3. So 1/12 is a little bit smaller than 1/11. So 3 is a little bit more than 1/4 of 11. So y is 3/11ths of the number of units in the horizontal direction. And also notice that the coordinate for y is equal to 3 units because y equals 3 in this case. So this point right here has a y coordinate of 3. It's 3 units in the vertical direction. But the x coordinate is not 11. We have to add 2 units back. Because notice that this is some number minus 2 got to 11, got to this, some number minus 2 got to this number of units in the horizontal direction along the x-axis. So we have to add those 2 units. We took 2 units away to get this to be right next to the origin. So we have to add those 2 units back. So if we add those 2 units back to 11, what is the x coordinate right here? What does that equal? Well, that equals 13. So we took the 2 units away to figure out the horizontal distance, the number of units in the horizontal direction. So we have to add those 2 units back to that 11. So we have to add these 2 units back. So this shifts over 2 units, and this point ends up at x equals 13, which makes this point up here x equals 13, but in this case y equals 3. So the points on the line, one point on the line is 13, 3. So if we draw the axis, now we know that this rests along the x-axis because this is y, not y minus or plus something. So that coordinate right there, y minus 0 equals 3. So this is right on the x-axis, but it's shifted over along the x-axis away from the y-axis because we're taking 2 away from the value for x. So we're subtracting these 2 to get to the origin right here so that we can figure out what this horizontal distance is. So 13 minus 2, remember this is 2, 0 right here. 13 minus 2 shifts this over to 0, 0. So 13 minus 2 is equal to that 11 right there. So remember that this ratio is the number of units along each axis. It's not the coordinates of each axis, it's the number of units along each axis. So this is 3 units along the y-axis, and this is 11 units along the x-axis. So this is the equation. Y minus 0 is y, and x minus 2. That ratio, the number of units in each direction, is 3 to 11. So what that's telling you is the number of units in the vertical direction is 3/11ths of the number of units in the horizontal direction. So again, that's a little bit larger than 1/4. 3/12ths would be 1/4. 1/11th is larger than 1/12. So 3/11ths is a little bit larger than 3/12ths. So a little bit larger than 1/4. If you just look at it, you can kind of imagine that this is 1/4 or about 1/4. 1/4, 2/4. 3/4, 4/4. You can kind of imagine that. All right, so let's build a little table here. So if we use an x value of 13 right here, this is 13, 3. So 13 minus 2, so an x value of 13 is going to be 3/11ths of 13 minus 2. Remember, we have to take away that 2 to move this to the origin. So 3/11ths of 13 minus 2. This is the number of units in the horizontal direction. So 3/11ths of that number of units is the same as 3/11 of 11, so now it's 11 units. Well, 3/11 of 11 is 3. If you have 11 things, 3 of them are 3 of those things. So if the x-coordinate is 13, the y-coordinate is 3. It's just 3/11. This is 3/11 of the number of units in the horizontal direction. All right, so that 11 is important in this case, because now if I use a multiple of 11, 2 times 11 is 22, but then if I add 2 more units to that, that's going to get me to 24. So that's going to put this point out here at 24, because 24 minus 2 is 22, and that number of units in the horizontal direction gets doubled. What happens to the number of units in the vertical direction along the y-axis? Well, that also gets doubled. So that's going to go to 6. So 2 times 3 is 6. Well, how do you get that from the equation? So 3/11. So now I'm going to use as the x-coordinate 24. So that 24 minus 2 is shifting this whole triangle over 2 units to the left. So this number of units in the horizontal direction is now going to be 22 units. From this point right here to this point right here is 22 units. This direction is 3/11 of that. Well, what's 3/11 of 22? So 3/11 of 22, so here's the 24 minus 2 right here. 3/11 of 22, well, 22/11 is equal to 2. 2 times 11 is 22. 22/11 is 2. So 3 times 2 equals 6. So if you keep going through this is where students get messed up on the arithmetic. They're not used to working with fractions. Just have to practice. You just look at it and think about it. Think about what 3/11 is. Think about how 22 is related to 11. 2 times 11 is 22. So 22 divided by 11 is 2. 2 times that 3 is 6. All right, a couple more points. If the x value is 2, what's the y value? Well, that goes right through this x-axis here. So if the x value is 2, y is 0. So use that in the equation for just a moment. So here's the equation right here. If x is 2, what's 2 minus 2? 2 minus 2 is 0. What's 3/11 times 0? That is also 0. So y is equal to 0. So x minus 2 is 0. That puts it back here. So y is 0. All right, one more. And this one is kind of tricky. I decided I'm going to use half this length, half of 11. Well, half 11 is 5.5. So what's that point right there? It's 5.5 units along this axis. So it's 1, 2, 3, 4, 5.5. But what's the x-coordinate right there? Well, the x-coordinate is you have to add these 2 units back. The x-coordinate is going to be 7.5. So if the x-coordinate is 7.5, then what's this length along the y-axis? So look at this carefully. I took half of this length. So that means that the y-axis is going to be half of this length. Well, what's half of 3? Half of 3 is 3 halves. This is 1 half, 2 halves, 3 halves. So 3 halves is right here at, well, let's see, I messed that up here. 1, 2, 3, 4, 5.5. 3 halves is right here, sorry. So 3 halves is right there. So plug 7.5 into the equation. So what's the first thing you're going to do? You're going to subtract these 2 to get this to be at 0, 0. So 7.5 minus 2 equals 5.5. So that's now saying that this length along the x-axis is 5.5 units. Well, if this length is half, if this length is 2 times what the length in the vertical direction is, then this length along the vertical direction is going to be 3 halves. I'm getting a little bit confused there, but that's okay. So 3/11 times 7.5 minus 2 is 5.5. So what's 3.5 times 5.5? You know it's going to be 3 halves. You know it has to be half this length. So 3/11 times 5.5 is the same as, 5 is the same as 10 halves. Plus 1 more half is 11 halves. Well, 3/11 of 11 halves is equal to 3/2. And these are hard to think about. You're taught to just kind of go through the arithmetic, but try to picture 3/11 of 11/2. You have 11 things called halves. 3 of those are 3 of those halves. So 3/11, these 11s cancel out and you're left with 3/2. Hard to think about. So this length right here is, the x-coordinate is 7.5, the y-coordinate is 3/2. And here's the line. Now you can draw the line. You have a bunch of points along that line. You can draw that line. You might think about what the coordinates of this point are right here. If x is 0, so you're not going anywhere on the x-axis, you're right here. If x is 0, what's the y-coordinate? And the answer to that question is the y-coordinate is a -6/11. So notice it's a little bit more than a -1/2. So how do you get a -6/11 as the point right here? Well, if you plug 0 in for x, 0 minus 2, what's that equal to? And then you multiply by 3/11, you're going to get a -6/11. So notice this is a -1 right here. This is a little bit more than a -1/2. It's a -6/11. So -1/2 would be the same as a -6/12. Well, a -6/11 is a little bit more than that as far as the length along the y-axis in the negative direction. So think about that for a bit. And that's it. There's a lot going on in a problem like this. And the most important thing, I think, is to realize that if you look at this equation right here, this tells you it's not a proportional relationship because this is not just simply y over x. If it goes through the origin, it's just y over x, and everything's proportional, and things are much easier to work with in those situations.